Hello my dear students. Uh, Today I will give you a lecture on some review of Smith chart. What is a Smith chart and how it really operates? The Smith chart is basically designed to uh, get the impedance of the transmission line and SWR of the transmission line, the standing wave ratio of the transmission line, and also it is helpful to find out the impedance matching. Okay, so how the Smith chart really constructs? Here you can see that there are some circles out of it. There is a circle, and for this circle there are some smaller circles outside, and there are some curved lines that emerges from this point to that point. How that become? First of all, if I zoom this thing, you can see that in this complete Smith chart there is a line. The center point is 1, and that is the resistance component or conductance component. This line is known as resistance component or conductance component in the transmission line. Here you can see that here the point, there is a straight line goes through it. I will draw your attention these points, point 1, point 2, point 3, all around in this straight line that goes through it, and that is the center point, that is the 1. Whether the resistor is 1 or conductance is 1, because we know R plus j omega L or R minus j omega C or G plus j omega C. If you want to construct or if you want to give the value onto this point, so we have first of all we have to plot this. Okay, so there are some circles, unity circles, different circles out of it. As you can see here, there are different type of circles, and you can see there is a line, there is a word written here, angle of transmission coefficient degrees. That is the angle of transmission coefficient in degrees, 10 degree, 15 degree or around this, and that is the angle of reflection coefficient in that particular point. That is the part of reflection coefficient, that means gamma, and in that particular point, that is the transmission coefficient T. Okay, so that's not the fact, but the main factor is that these are constructed by these circles. As you can see, there is a smaller circle, there is a larger circle, there is again a larger circle. These circles are known as this is circle. These circles are known as the real value. Real value means that's not the imaginary values. That means resistance or conductance. So these values that has been drawn from here to till that it will go to the this part, that part. Here you can see in that part. So these things are particularly the real value or value of the resistance or inductance, and that is known as the real value of the circles. Circles are the real value, and there are some curved lines out of it. These things are particularly known as these curved lines are known as the imaginary parts. That means it can be capacitance and it can be inductance. The main point of view is that this part is the point of inductance. That means the value of L, j omega L, value of j omega L, and this part are really the capacitance. The value of j omega C will be drawn. Okay, if it is a straight line, so the upper part is dedicated to the inductance and the lower part is dedicated to the capacitance. These things are plus and these things are minus. Okay, so if anybody tell you that how can you plot such inductance here. Okay, if the impedance or characteristics impedance is we know R plus j omega L, that means the value of R will be 3 ohms, and the value of the j omega L, the total ohms should be, if it is 2j. Okay, if that is the impedance, how can you plot it? So first of all, you have to find in this straight line where the 3, where we can find out 3. Okay, that is 1.0, that is 1.2, you can find it now, that is the 3. So that is the circle that the 3 crosses into the straight line, that is the point. Okay, the straight line is circle that cuts the straight line, that is the circle that cuts the straight line, that is the 3 number, that is the 3 resistance. And if you want to plot the inductance, where should you go? You should go upwards in this kind of curved lines. Okay, not any circles. Okay, that emerges from the point center of this. Okay, so if it is 2j ohm, so whether you will plot it, whether you can find the value of 2 or 0.1, 0.2, whether you can plot it. So you have to first of all you have to find out that is the inductive part and that is the capacitive part. Okay, so you have to find the value from these values, because if it starts from here, when the curve ends here, that is the value of the curve, that is 5, that is 4, that is 3. Okay, that is the value of the curves. Okay, if you just go up onto there, how that can be deal. Okay, so first of all, there is the value of 3, and if you want to find out plus 2, where is 2, you can go on to roam around this circle. Whether the 2 comes, that is the 2.0 comes, so that is the point of inductance. Okay, so in what point the curve and the circle, the circumference of the circle cuts each other, that is the curve that travels through here. You should go there, just travel through there, travel through there. Okay, and that is the real value. That means 3.0, just travel through to this circle. Whether the point cuts, here is the point. Whether the curve and the circle cuts, so just point this, that is the point of confliction, and that is the point of the z naught equal to r plus j omega L. You can now really find it, r plus j omega L, that is 3 plus 2 j ohms. Okay, now if the value of these two, if we say the value of these two been changed, if I change the value, okay, if I change the value, that will be 1, and that will be 0.5j, what will be the point? So that is the point 1, the circle will roam around this point of view, this line, this circumference. And where is 0.5? We have to find it from here by roaming here. Okay, where is 0.5? Here is 0.5. You can see there is the 0.5, the point. So now you have to go through to the curved line. Okay, that is the point of confliction that cuts through there. So that is 1 plus 0.5j. Okay, so